In this video, I'll tell you what are the relative max mean of a function and where do they occur. So let us start with what is a relative maximum. I will write most of the time as max, or minimum of a function f. Well, I assume that you understand what does maximum minimum mean, but what is relative? This is a technical word that you have to understand. Let me show it first through a graph of function. Let's say our function is like this and then goes up there and then goes down, something like that. You see, relative means that it's not necessarily a maximum or minimum. What is important? It is maximum only around that point. It's a maximum around that point. That relative means that it is maximum only around that point. Maximum around that point. When you look at it, that point, that point is the maximum, or it is minimum around that point, and the same goes here. Well, maximum and minimum relative, then in definition, the precise definition, I have to say first of all, it is the value is bigger than everything else, but I have to make sure to kind of include what does um, around the point mean. So let us just start with the point that let f be a function defined at a point C. Let's see. Then f at C is a relative maximum, I'll just write max, of f if, well, I want to say that f of C is bigger than equal f of everything else, but not all everything else on the real line. What is important for me is that fc is only bigger than f of x's, which are, for x's which are close to c. In other words, if there exists, this is how we put a neighbor around a point. If there exists an interval AB, this interval contains C, and for all x's in this interval, we only need one interval around that point. The value of the function at C is bigger than value of everything else in that interval. That's called relative max or relative maximum. And if C is a relative mean of f, if, well, value of the function at C is less than equal to value of the function at any other point in an interval around C. So if there exists an interval AB, this means around containing C such that f of C is less than f of x, meaning that it is minimum. Yes, it is less than everything else. Only for that, for all x in that interval. Well, if so, let me just close. That's the definition, the precise definition. Well, we need to continue because there are a few terminology. If C is a relative maximum or minimum of F, then, well, if you don't want to emphasize if it is max or mean, you use another word. Then we say if C is a relative extremum of F. And well, if you want to, this is the value. The extremum means either relative max or relative mean. But also sometimes we want to say that uh, and that extreme relative extremum happens or occurs at C. So if at C is relative extremum. So that's the definition. But well, uh, where does a relative extremum occur? Because this is the goal of the next two sections. We want to find relative extremums. So we need to see where such a thing happen. Well, if we are supposed to find all the points, that's a lot of work to do. Here, there is a very important fact, and it comes from very nice and easy observation that if I have a relative max at some point and the function is differentiable at that point, the function will look like this. It will go up, 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 and then at some point, the point which maximum happens, the, the tangent line is horizontal. That means that the derivative of the function at a relative extremum point is 0. Or, well, it can be something like this. It can go up, go down, or go up, go down. And these points, the derivative does not exist. So it doesn't have any tangent line. What it means is that either the derivative does not exist at those points, or if it exists, that derivative needs to be 0. We already know what are such points. So this I'll write it as a fact. If F has a relative extremum at C, then C is, remember the name, if a function has a derivative 0 at a point, or the derivative of that function is not defined at that point, we called it is a critical point. That means either F is not differentiable at C, or it is differentiable and its derivative is equal to 0. So this is a very important fact. If someone is looking for relative extremum, you have to start with finding critical points, and then in the next video I will tell you how you can detect if a critical point is relative max or relative mean.